Okay guys, so now we continue with the third mechanism of alkenes, which is hydrations. Okay, before this we already learned about dehydration of alcohol mechanism and then hydrohalogenation. So this is the last mechanism for alkene, which refer to the reaction of hydration. Class, for this hydration reaction, we also have three steps. The first step is formation of carbocation. We know that for hydration, alkene will react with acidified water. Kalau you still remember, alkene akan react dengan H2O in the presence of H3O+ or acid or strong acid. So here we have alkene kat sini, kita ada 2-methyl propene. So this is the alkene. So kita terus react with H3O+, bermaksud acidified water. So what happened here, as we know class, we already learned in chapter 4, alkene is nucleophile. Sebab double bond adalah kawasan yang kaya. So bermaksud alkene akan attack H3O+. So we know that H3O+ positive. Bila positive charge, it should be our electrophile. So electrophile is electron deficient. So that's why alkene will attack this H3O+. So dia akan attack satu hidrogen sahaja. Bermaksud dia akan ambil satu hidrogen sahaja. So what happened here? Bond between this hydrogen and oxygen will move to oxygen. Nampak tak? Arrow yang kita gunakan adalah full-headed arrow. Saya kata full-headed arrow if movement of two electron. I'm sorry. Okay, so full-headed arrow adalah pergerakan 2 elektron. So kita tahu dekat sini satu single bond consists of 2 elektron. So both electron here will go to oxygen. So dia akan dapat ni, nampak tak? Asal dia ada satu sahaja lone pair, so dekat sini dia dah jadi 2 lone pair. Okay, so this double bond will attack this hydrogen. So hydrogen ni akan masuk kepada carbon double bond yang banyak hydrogen. Ini akan follow Markov-Nikov rule. So that's why dia dapat CH3 dekat sini. Asal dia adalah CH2. So no more double bond here. So this carbon lack of one bond. So that's why it will form carbocation. So the type of carbocation here is tertiary carbocation. So be careful guys. If we have the formation of carbocation, so it will dia juga boleh berlaku rearrangement, either 1,2 hydride shift or 1,2 methanide shift. So but in this case, dia takkan buat apa-apa rearrangement because the carbocation form already stable. Sebab apa? Sebab jiran dia kiri kanan atas ni semuanya primary. Awak tertiary, takkan nak berubah jadi primary, betul tak? So no need rearrangement here. Tapi you need to be careful. Sometimes dia boleh berlaku rearrangement if the carbocation is unstable. Okay, so this is the first step, formation of carbocation. The second step is formation of protonated alcohol. Okay, so what happened here? Okay, the carbocation will react with the H2O just now. Ni dia akan react balik dengan air yang ada. So, as we know that H2O consists of 2 lone pair, it means that this H2O is nucleophile, electron rich species. While we know that carbocation is electron deficient species. So siapa yang nak serang? Saya dah kata, yang kaya mesti serang yang miskin. So one of the lone pair here, nampak tak? Dua-dua lone pair ni akan diberi kepada carbon untuk membentuk satu single bond. Nampak tak kat sini? So tengok pergerakan arrow tu daripada lone pair kepada carbocation. So this lone pair, no more lone pair here. So that lone pair here will become a single bond. Nampak? So what happened to this oxygen? Dia ada positive charge. Kenapa pula dia ada positive charge? Sebab dia donate, kelas. Ingat, bila kita donate, kita dapat positif, kita dapat pahala. Kan? Konsep dia macam itulah. So this oxygen jadi positive charge sebab dia ada 3 bond kat sini. We know that the maximum bond of oxygen should be 2 saja. So this we call as protonated alcohol. So macam mana nak jadikan alkohol sahaja, not protonated alcohol? So we need to remove one of the hydrogen at oxygen here. Kita kena buang hydrogen ni, salah satu. Okay, so the third step is elimination of H+. So how? Like this. Okay, kita ambil semula protonated alcohol kita ni tadi. So dia akan react with the other H2O. H2O molekul bukan ada satu je, kelas, betul tak? Ada banyak. So one of the H2O molecule here, so what happen? One of the lone pair at H2O will attack. Dia akan ambil semula H. Tak kisahlah H yang ni ke, H yang bawah ke, mana-mana pun boleh. So dia ambil H ni. So we know that this bond oxygen with hydrogen here, we have one single bond here. So this single bond akan bertukar menjadi lone pair. Nampak tak? Okay, so this bond will move to oxygen, become a lone pair. Nampak? Asal oksigen kat sini ada satu je lone pair, so dia jadi 2 lone pair. So here H2O will become H3O+. So lone pair yang ada pada oksigen ni, semua lone pair ni, okay, so nak tunjuk boleh, tak nak tunjuk pun tak apa, kelas. Sebab kita bukan lukis Lewis structure. Kalau you tak tunjuk pun kita accept juga. Okay, so tapi arrow daripada mana ke mana tu mesti betul. Mesti macam ni, dia mesti daripada oksigen kepada hidrogen. Yang ni bond kepada oksigen. So you kena hati-hati bila bermain dengan arrow. So the product form here only one product. But if it will involve the rearrangement, sometimes you can produce more than one product. So you need to be careful with the first step, formation of carbocation. So the step here 1, number 2, number 3 ni kalau tak tulis dalam exam pun tak ada masalah. Yang penting step awak tu ikut one by one. Okay guys, so this is the example how to write the mechanism of acid catalyzed hydration for 1-butene. Okay, kita tengok contoh. Dekat sini saya ada 1-butene. So macam mana kita nak buat mechanism dia? Okay, bila dia react dengan acidified water. So 1-butene react with H3O+, terus direct H3O+. So nampak? So siapa yang nak serang siapa ni? Ingat, double bond ni, dari double bond akan ambil hydrogen. So like that. Nampak tak? Okay, so the bond between hydrogen and oxygen here will break, become a lone pair. Nampak? So 2 electron here will move to oxygen, become lone pair. So you akan dapat carbocation here. So the type of carbocation here is secondary carbocation, and then it will produce H2O. See? So asal dia ada satu lone pair, now dia ada 2 lone pair. So lone pair ni kalau tak nak tunjuk pun tak ada masalah. But be careful here guys, at this carbocation sometimes it will undergo rearrangement, but this case no rearrangement involved. Why? Because this secondary carbocation already stable in this compound. Why? Look at the right side here, the right side carbon, primary carbon. So dia punya stability lagi rendah daripada yang asal. Look at the left side here, same stability with this one. So no need rearrangement because tahap level carbocation dia ada yang sama, ada yang lebih rendah. So no rearrangement here. So now this is the first step. Nampak saya tak tulis pun formation of carbocation. No need, class. Okay, kita teruskan lagi with the second step, protonated alcohol, formation of protonated alcohol. So this H2O will attack the carbocation. So one of the lone pair here, nampak tak? Daripada O kepada C. Okay. So apa yang berlaku, you akan dapat protonated alcohol. See, no more lone pair here. One of the lone pair here will become a single bond here between carbon and oxygen. So when oxygen consists of 3 bond, so dia akan jadi positive charge. Ataupun sebenarnya sebab dia dah donate lone pair tadi, sebab tu dia dapat positive charge. So we don't want the protonated alcohol, we want alcohol only. So we need to remove one of the hydrogen here. So the other molecule of H2O will react, okay, will attack this protonated alcohol. So tengok arrow dia daripada lone pair ni ataupun daripada oksigen will attack the hydrogen atom. Tak kisahlah hydrogen yang ni pun boleh, yang ni pun boleh, mana-mana. So bila dia dah ambil hydrogen ni, jangan lupa we have the other arrow. Nampak tak? So from bond here will go to oxygen. Okay, asal dia ada satu lone pair, dia akan jadi 2 lone pair. Maksudnya lone pair tu adalah elektron berpasangan yang tidak membentuk ikatan. Okay, so that's why we got the final product here. So kita dapat alcohol here. So kita dapat the side product is H3O+. So remember class, the lone pair here kalau tak nak tunjuk pun tak ada masalah. Tapi bila you tunjuk, you lagi faham dan lebih baik. Okay guys, so ingat at the formation step, formation of carbocation step, you need to be careful because sometimes boleh berlaku rearrangement. Okay guys, that's all for the mechanism of alkene hydration. Bye guys, thank you.